Okay, let's give this a try. Hello guys, Mark Wood here. Hey, I want to show you what I've been doing. And I posted some pictures and some information on the Facebook control line group about my electric power pod here that I'm building for my Franken laser control line project airplane. And so in the process, I bought this laser. You see this thing over there? I bought that laser to make parts with. And I was thinking that it would be mutually beneficial to use that to make pieces and parts that other people could use. And this electric motor power pod would be very suitable for just about any profile model that you want to convert to electric power. There's some conditions, of course. You know, this particular piece is about 8 inches long or so. There's a scale right here, and as long as that seven and some change, as long as that will fit on the front of the airplane, and it's 2 inches tall. As long as it fits on the front of the airplane and in the mount beam provisions, this power pod will go in. I have this Shoestring airplane over here that I've been flying, and it flies very well. I like the way it flies with electric. Electric power is growing on me a lot. I'm a motor guy, just like a lot of you guys are, but this electric power is something very, very nice. So I'm going to spend time developing some very interesting electric ideas and so forth. So the power pod here that I built, I used a lot of my experience with running electric RC, electric helicopters, running this Shoestring, and I learned a lot of things along the road. And my biggest experience with the Shoestring was that it was not cooling adequately. Just plain isn't getting enough airflow through the cowling. And there's two parts of airflow and power cooling a power plant. You have to let enough air in for it to move through the power system, and then you have to let it out. And you can see on the back here, I've got the cheek cowls opened up, and I've got some vents on the top in where the wing interface is, and then on the bottom. This cowl opening here is something that I had to do on my large laser in order to get the cowling to ventilate well enough to cool that engine. It didn't take a lot. It just took a small couple of cuts on that particular aircraft to get it going. But in the process of designing this, you know, I looked around. I saw things that I liked that what different people did, and how they went about integrating their systems and so forth. And I found that I liked a particular kind of style. I very much like this Annulus type of cooling system. And you can see what happens is the air comes in, goes around the spinner, goes in this little gap right here, and then it flows into the engine, into the motor. The area of that Annulus right here is the same area as these particular vents that go into cooling the motor windings. So this motor is running, and airflow is moving into these channels and through the windings to help cool the motor. The other routes through are through these cheek cowl openings, and then they blow into the compartment. One of the things that was important for me is that we have good access on the in the system. And this is an early version, and what I found was we really need to have a support in this to hold a battery. And I will show you this. This is what we would call the pre-production prototype. And it has a battery standoff inside. It took me three iterations to get that standoff to work in a way that I really kind of liked the way it ended up going. So there's enough provision in here to be able to route the wires. Wiring was always been a problem with the other airplanes that I've done. It seems like when that design was done, there was little thought taken to seriously routing the wires, and so I spent several iterations making that work in a manner that I really kind of liked it to go. You may be able to improve. If you were to purchase one of my kits, there's enough room and opportunities to make it work better, and I did that with the intent of giving people opportunities to do their own kind of integration work. So if you pick this one up here, we'll put this back on because it looks a lot cooler when you have this on. The little cowl has a little magnet on it, and this particular cowl piece was originally made with this unit right here. I've made I don't know, 4 or 5 of these things now along the road, and any one of them, including the first one, would have been able to be installed in an airplane and flown. But my mission was to build something that not only could I use, but I could provide for other people to have and use in their airplanes. And you can think of a lot of neat little ideas that you could build into a little profile model. Basically, there's some lines here that you can put in to line up and glue this into your airplane, and there's enough bond area to hold on to the airplane. One of the things that I found in building these airplanes was not sufficient bond surface for things to glue, so I added another piece of the plywood into the stack to make this work well. This is a pre-production prototype, call it that, the final critical design review piece. And you can see here, if the motor was in here, we could route the wires up through this channel right here. Here's the speed control, and the wires will come back quite readily to interface and plug into the motor's wires. A couple of airplanes I had to really work with the hemostats to plug those plugs in. It was a real pain in the tail. It took me an hour and a half just to plug those 3 plugs in. Well, not really, but it sure seemed like it at that time. So if we look at it on this side here, this is the hatch. The hatch comes off, and it exposes the motor. You can see right here where the wires can route through and come out this place right here, and there's just enough room here for that pigtail to have a connector on this end, and then the battery can plug into that connector just like this. The magnets and the Velcro straps will come with the kit. So this kit, when I produce it and send it out, will be complete, ready to run. And so the battery can come out just like this. Comes out this way, so that it's readily accessible. And then here's the strap. And then inside below is the speed controller, and there's this very small piece right here. It just plugs in. I need to write on the kit, do not glue this in, because this piece goes in just like this. Supports the battery, comes out whenever we want to pull this speed control out. Speed control comes out just like this. I've got this signal cable kind of wadded up inside, so you can also put this back in. This particular version does not quite have enough room in this bridge right here, and in the production version we've got a little bigger bridge for those wires to route more neatly. But I think it's going to work out just fine. I'm going to put one together tonight. Doesn't take very long. I've done enough of them. It probably takes me 10 minutes. No, I'm lying. It'll take me longer than 10 minutes. About an hour to assemble And to cut the pieces out of the panel takes me about 40 minutes. It's quite a bit. There's a lot of bits to this thing. Bits, as the English say. So this is how the kit will come. There's a sheet of plywood here. It's all the plywood parts, and this is all the motor pieces. These are the sides, and then this is the motor pieces. This is the battery support, and these are formers. This is the first row of the engine mount, motor mount, and then these are the other motor mounts, and then these are cheek cowl forms. The way this goes together is there's some index marks in here, and the way this goes together is you sit it with the bottom, and the next piece goes on like this, and the next piece goes on, and they just wrap around as you assemble it. At least that's what my plan is. Seems to work pretty good for me. And then these are the cheek cowl pieces right here. This one and this one are cheek cowl pieces, and then these are rings to make the motor mount ring. And I made them out of 1/8 inch balsa wood intentionally, because what that does is it allows you to form plywood. The wood is fairly brittle whenever it is in one piece, and if you squeeze it the wrong way, it breaks. In fact, once in a while I break one of these parts putting them together. Here's the stack of the rings, and so my intent is when you put this stack together, you just alternate the grain directions like so until you're finished. And then glue all this together. I glue it together from the inside so the outside sands nicely. You can sand the inside, sand that burn off before you put them together. They'll look nicer. And then there's a little guide ring right here. I put guide rings and marks onto everything, and they're not anything special. I just put them there so that it's easier to form the nice ring. So when your parts come out, they come out like this. These pieces are the cheek cowl nose pieces. I started off making the cheek cowl pieces out of balsa wood, but what I found was that the balsa wood was not sturdy enough to handle the cheek cowl bits like this right here. Not sturdy enough to handle this when we're sanding the parts. Like this piece, in order to make it fit, we're going to put it on a piece of sandpaper just like this and sand it, and I was breaking the formers. So I just went and made these pieces out of plywood in order to support that structure and keep this stiff enough to glue together and handle while you're doing that operation. So another thing about the motor mount ring, you'll notice, is it's got these 2 notches on it. On the front of the front of the pod, the engine mount area has these bosses sticking up, and the intent of those is so that the ring can fit over them. This is an early version, and that piece was sticking real far up, and I didn't like the way it worked, and they were too big, and so I didn't like the way they worked. And 2 or 3 iterations later, I got this where it would work pretty good, and it just snaps in, locks in place. And I'm not going to do that with this piece right here, because it's really quite fragile until it's glued to the other pieces. You squeeze on it too hard and it breaks. So let me set these aside, and I'll show you how this thing goes together. It's actually fairly interesting. This is my first experience and my first effort at doing any kind of design work for an interlocking design. Before we started here, I did take this. This is the end firewall, and you build this whole pod up like this, and then this piece glues in last from the outside, and we use these holes as guides to drill through the other piece of the firewall engine mount, motor mount. So I did this on the drill press, so I got really good holes, and then I can just use those pilot holes to drill through it with my Fordham or my hand drill. See, this goes in like this. I'm gonna just use those to drill through later on when it's all assembled. and it'll be real accurate, and the motor will bolt in just fine. This piece is the tongue piece. This is our hatch, so that part glues on to the hatch side, and the hatch side comes out of this panel right here. This is the inboard panel. So when this is on the airplane, you got the wrong side. When this is on the airplane, this piece right here, the cover will be on the inside, so that centrifugal force tends to blow this, push this out in that direction. So the only thing that has to happen here is that the magnet keeps this closed, and the tongue keeps it from blowing out. So between the magnet and the tongue that's on the front, this should be quite secure. And this former is the first piece that we're going to install. This former is the front edge of the oh, that drives me crazy, those little nubs. This is the front former of the cowling. It goes right here, and you notice the little notch right here kind of conforms to this. The part that, oh, see, that came apart already. This is the top piece of the former of the cheek cowl is this right here, and these pieces notch into that. That's the idea behind that. And then this is the intermediate. I could have made 4 of those exactly the same, but you know, AutoCAD can do what we want, however we want. Sometimes we don't think of that stuff until afterwards. And this is the magnet holder. This glues into the back of the frame after we're done. So I'm just going to set these parts aside for the time being, because what I want to do is I want to have these box pieces in place and in hand. So you notice this is the front engine mount piece, and it's marked up. This will only go together one way. It will only go together with the drill locating X's out front, and with this piece on the upside, and with that, this will go together. These tabs are different sizes, and so are the tabs in the box pod formers. This particular part goes behind this part, and it has a pocket for the tongue. In operation, like this tongue goes in just, and it holds this in place. So this piece, the cheek cowl, goes in, latches in, comes back out, and this piece it helps do that. And so here is the inboard former, and these parts go together just like this. So you can see how that integration works. So when we glue this piece right here into here, it forms the latch. We could do that now, or we could do that later. It really doesn't matter. But you know, that's kind of up to you. If you want to do it that way, that's great. But the design here, I'm going to walk you through how this was intended to be assembled. So the first piece I'm going to pick up is I'm going to pick up this outboard piece, and it says up. This part right here is going to go in, and it's going to interlock in just like this. Once that part's in, sand some nubs off real quick. Before I started this, I went through and I did some just basic sanding on all these little notches where where we're going to glue this together, because the CA glue is not real happy about gluing to the charred parts. It will, but it's not real happy. Now notice right here that there is a mark. There is no mark, 1 mark, 2 marks, and 3 marks as we progress through this assembly sequence. So we're going to put these 2 pieces together just like this. That piece is going to go in here, and somewhere I have a tape clamp handy, and I'm going to take this Yeah, it doesn't really matter where I'm going to tape it, but I'm just gonna tape this corner real tight right here. I'm going to tape another corner real tight right here. And another thing that I'm going to tell you is that I grew up using Eastman 910 in the late 60s and early 70s. Bill and Bob Hunt, Satellite City were the ones that started marketing that and using it. They used it in the space industry to glue rockets back together again. So here's one thing I want to tell you. The motor has a 1 degree out thrust alignment to it. Now that I have this together just like this, I'm going to use my thin CA. I'm going to put this together, and if you want to, you know, you can take your block and you put this together, and you can get it all secured and so forth. One thing that's kind of important is that this former fits up tight right along that particular piece right here. And so I'm going to get this thing all squared up. It should be squared just by the simple fact of holding it tight together. And I'm just going to put a couple of drips of CA glue in right here, and I'm going to push it together and hold it for a second or 2 or 5. I'm not going to worry too much about getting CA glue all over because this is all on the inside. Now hold it, and I'm stuck to it, which is good. It's a good sign, means the glue is getting through. I have the fix for that. It's right there. It's called nitromethane. Did you ever wonder why the front of your airplane falls apart when your fuel tank leaks? I'll tell you why it falls apart when your fuel tank leaks. There's no better solvent for cleaning up super glue than nitromethane. You can get super glue out of your clothing with this. I bought a whole gallon jugs just so I could have that because I got super glue on one of my favorite shirts. Acetone won't work for that. So I'm just gonna get this in here, get it going. I do use the gap filling. Don't have a paper towel handy. Here we go. Wipe that off. Here, watch. See that fingerprint right there? Yeah, I hate sanding super glue, boy, it sucks. Here you go, watch this. Doo-doo. Done. Isn't that awesome? Yeah. We like that. So I got a little bit of a gap right here from the laser curve when it's cutting. I also was kind of focusing right here where this beam mounts. So I'm just going to use some gap filling in here, just in these spots. This interlock method would be just fine without doing this right here, and later on when we sand this thing, it'll fill up, those gaps will fill up with sawdust, and you can just put a little drip of super glue in, and when you put that little drip of super glue in, it will fill that gap. Yeah, now see, this thing is already really nice. Okay, so it's a little bit of a free-for-all from this point, and my messing around the other night kind of puts you in a place where you kind of want to do this right here. You want to put these in, and these guys go in like this, and I'm not going to glue this in. This one's a little tight, so I'm just going to reduce the height of this right here just a little bit. So I'm going to put it on my sandpaper, take a few thou off. I'm not super anxious about how tight this fits, because I'm not going to glue it in until I've got everything in place and I've got it lined up, and then I'm going to glue it in. Yeah, and it wants a little bit of adjustment to this notch right here. There it goes. Just like that. Put it in, take it out. Put it in, take it out. There. Close enough. Do the other one. Probably is a little bit, should have taken a little bit off the top on the other one. It might have been the top side that was giving me fits. We'll just give it a little bit of room here. There it is. I don't want to glue this all together just yet. I could take this piece like this and put it down in there and get it all lined up. And I could glue that. I could glue that in. I could glue both those pieces right here in. What I really want to do is I want to get my end former in first though. And you notice the end former also has an orientation to it. And so this is going to go in just like this. Okay, Charlie, what do we do here? And yep, it's going to go together. So it's in, just like that. Put it all together. Looks good. We're going to tape clamp it. I don't always tape clamp. More often than not, I just glue the parts together, holding it, and get my fingers in it, make a mess. That's why I got this. Cleans up my mess. I'm messy. You guys already know that. Okay, so that's all lined up and it's good. And it looks good and square. I got another square here too, could do that. Same thing, who cares? In there, push that in. And now we're just gonna go ahead and glue those in place. Get these out. I'm gonna push down, make sure that those go just right. Glue these in. These channels right here are for the wires. These right here for the speed control wires for the battery. Now I originally intended for the battery wires to come out on the inboard side right here, and when I was putting this thing together, I noticed that there was a good alignment here, and if you decided, you could run the wires out on the outside. It's probably not real convenient to run your battery through on this side here, but if your speed control wires were long enough, you could come out and go through the fuselage and connect this way. I don't know. There's like 100,000 different ways you can do this, but the intent that I had was that when you put your battery in, you put the cable through like this, and then the battery mounts like this. There's a place for the charge wires to go. These things tend to be forgotten all the time, and you got to have a place for them to go. They can lay down in here when you're putting this into the airplane, and then this can go in and land like this. And then the Velcro, the little Velcro loop goes around here to hold this in place. And my intent with the Velcro loop was that it separates the speed controller from the battery, because what I don't want to have is I don't want that speed controller laying right along the battery connected right to it, because that battery needs a lot of air, and so does the speed controller. You know, these MOSFETs in here, they need to get air flowing around them. So I wanted these two pieces separated significantly. So that's why I have these things in here. I was very reluctant to install this little spreader bar that's in here, and because it represents a dam, and it blocks airflow going through here, and so it causes turbulence around that battery, and it starves the battery from air. And this is why I have these exits right here. And the intent is when this is installed up against the wing, here's your wing, how it comes. The intent is to allow a little vent behind this on the front of the wing, and allow that air to come out in that vent also. The rule of thumb for a power plant is the exit area should be no less than 1.5 times the area of the inlet. So that's a challenge, and it's a pretty big challenge, and that's where most power plants struggle when we do our cooling survey. So here's the we've done the bottom, and we've done the outside, and we've done the top. You notice there's 2 marks right here, and there's 2 marks here. So these 2 pieces go together just like this. And you know, I'll just keep on doing this tape clamp thing. Here, put one right here. Put this. Tighten it up. Like that. Tighten it up just like this. Squeeze this in place. And we're going to let some CA glue get in those cracks just like this. And that needs to be squeezed down. So what I'm going to do is I'm going to squeeze that down and put some glue in there, and I'm going to hold it for a little bit so that it cures real quick. And yeah, I'm going to squeeze just like this because I don't want to distort that angle. And boy, see, that glue just came all the way through that plywood and got to my thumb right here. It's okay, I got the fix. I glued my sister to the refrigerator when we were young. She's being a brat. Held her hand to the refrigerator with the super glue. My mom was pissed. Oh, was she pissed? A little more glue in here. Yeah, see, all gone. Look right there, a little gap filling. Yeah, I know, glue isn't as strong as the wood. Yeah, we'll get over it. It'll fly. Hopefully it'll fly good. See, this is getting good and stiff already. Oh, guess what I didn't do? I didn't put these pieces in. Wonder if I can manage to pull that off. You guys are gonna laugh at me. You know, I can edit this out of this video. It's coming apart downstream. There it goes. Yeah. Okay, so this is why I added this extra doubler in here, is to double up the bond area. And in this case, I'm probably going to use, not probably, I am going to use my gap filling in here, and I'm going to open this up and let my gap filling get into that crack. And just because that's what I do, I'm probably gonna come back at some point and add some CA glue to that joint. Do the same thing right here. If your way of doing it is to just build this all with gap filling, that's fine. This is just how I do it. And then the next thing, what I'm going to do is I'm going to come in here and I'm just going to make this thing wet with super glue all around in here, just like this. All in these areas like this. The other thing that I'm going to do is I'm going to get all of these surfaces in here in this mount with super glue. Bond all this together. The places where people have trouble with these is around these mount holes. I've had trouble with the RC planes, having troubles coming apart there too, and usually it's because they just leave these cantilevered out and they go like this and leave little ends on them, and there's nothing to support that, which is why I did this way. If your motor needs the room in here, just use your Dremel to make that bigger. Because of the way this works, you're going to want to use, more than likely, the collet that came with your motor to make sure that prop adapter sticks far enough out that the spinner will work. This was designed around the Cobra motor, so other motors may or may not work. The Leopard, like what I'm using in the Shoestring, will work in here, but it has a 19 millimeter and a 25 millimeter spacing, which is why we have two marks on each one of those. Okay, getting down to the wire here. This one's a perfect candidate to do with the medium, because it's a little tougher to get in here and glue this with the thin, especially with a short tube on it. I got a whole roll of this tube right here. It's Teflon insulation. What I'm looking for when I do this, I'm looking for that drip comes out of the end of my tube to just run down that seam and run all the way to the end. I'm going to hit it with a little accelerator. Now, when you make popcorn with your accelerator, it's because you're using way too much accelerator. And enough accelerator, really, you could go like this, just spray this paper towel and just bring it in here and wipe it around like this. And that's enough to get that glue to set. What I usually do is I just spray it from about so far away. That part's pretty much done. See, we're ready for our cheek cowl to go on here. This. I don't know the perfect solution to this thing right here. It isn't super critical because we can fix it with sandpaper, but here's what I do. I get it all lined up, I glue it together. Hope you guys can see what I'm doing, because I keep pulling that in this close end workspace here. Be doing it like when you're doing handgun. Here it is. It's in my workspace right here where I can see it. It's on the same side as the battery pocket right here. Set that down, let it dry for a little bit. Sweet. Let's clean off the end of this tube. It's got a bunch of crusty super glue all over it. Now I got super glue all over me again. I got the fix for that. Where's the water? Okay. Let's make this part. That's 120. Super carefully. This is 120 grit emery that I'm using right here. What's on the bench is 220. What's on my bench is what I always, this right here, I always have a piece of 220 on the bench. My bench is a plywood main bench, and the work surface here is a piece of marble that I got for 50 bucks. keep your eyes out. There'll be somebody that's remodeling, flipping a house, and they'll have they'll sell off their scrap bits. Perfect for working on. Get super glue on it. You can scrape it off with a razor blade. I'm not going to form this tonight. I could. Doesn't take very long. It takes about 10 minutes. With the guide, it makes it pretty easy. All I'm doing is getting that charred balsa out of there. I don't want my grain lining up. See, so I've got my grain about 45 degrees apart. Then super glue. I didn't get them together perfectly, but that's okay. Be careful not to glue the next piece over that piece. I'm going to change the grain direction a little bit right here. Line these pieces up. Glue them together. Oh, I kind of squeezed it whenever I was putting it together, and I got a little bit of a distortion here with that ring. It's okay. We'll get over it. It's a handmade thing. If I was really worried about it, what I would do is I'd mount this up to a piece of wood, and I'd take it over my lathe and just machine it on the lathe. If I was trying to impress somebody, that's what I'd do. I'm not, so I'm just going to do it this way. Get me a big piece of dowel. Got one somewhere. Question is where. Was on the table here. Yeah, there we go. That'll work. Lycoming rod pen. Dude, these things are awesome. Good and heavy. Nearly perfectly flat. get a bunch of money to replace them. So you get the idea. I just make this thing nice and round, and then I'm going to shape it. Once we have that plywood shape, that plywood configuration, this is pretty stiff. Especially if you put glue in all that end grain. I'm going to bring this out to that line, kinda, not perfectly, because I want a little bit of roundness on the transition to the inside. And then what I'm going to do on the outside is I'm just going to get my my 80 right here, and I'm just going to work my way around this thing with this 80. Work it around slowly. And I'm going to make it, oh, I don't know, 1/16, eighth of an inch here on the end. About like that will work. I'm just gonna go and make that taper back and leave a little bit of a dark ring around the end there for a minute while I bring this in. All I'm going to do initially is just kind of make this taper just about this angle right here. If my bell mouth is too small, too sharp, I just take this and run it on my surface there, cut a little bit off the length, recover some of that thickness. You know, there's nothing set in stone about how this is supposed to be. Whatever makes you happy, that's how it's supposed to be. I'm pretty easily amused generally. Switch back to 220. I'll refine that a little better later on. I'm not gonna finish it tonight, but I will make it nicer. See, looky there, man, that's awesome. Okay. Make a cheek cowl. I'm gonna show you how to do a cheek cowl, and then I'm gonna sign off. I'm guessing Mama's wanting some dinner. These pieces are longer, fatter than they need to be. I've already got these pieces. I got those pieces laying out here somewhere, I thought. Nope, don't. We decided not to do that, so here we go. This baffle is intended to prevent the air from flowing straight through the cowling. You can see right here, if I let this airflow, it would just want to blow through here and then go in and go back out, and it would not go through and cool the battery. So we put this baffle in right here. And that baffle's job is to make that air come in and then blow to the battery and cool the battery. Did you leave me, Mama? This is my mama. She's a good mama. She takes care of me. I mean, check it out. She lets me play with model airplanes, and she lets me play with big airplanes and stuff. I changed my line type on the laser here, and it put these additional little tabs in. And there's a couple places where it makes getting these parts out a little more difficult than what I'd like. The first 3 or 4 of these things are going out with them. Sorry about that. Better than pieces laying all over your envelope that they come in. Now all these little tabs should be sufficient. The normal ones, they should be sufficient. They're borderline coming out easy enough and staying put. There's 2 pieces like this. There's the one with the round side. And that's the one that goes up front, and then there's a straight one that goes in the back. The straight one is going to get this web right here cut off. And that will allow the wiring or whatever else we want to do. See, like this. that's a nice tight fit on this one. Yeah. Super glue. Do a little tack right there real quick. Done. So here's the biggest challenge of this whole project is this is going to glue on like this. So what we got to do is we need to taper this piece right here. So the other reason why I went to plywood as opposed to balsa wood is because whenever I was machining this piece right here, I didn't have a good guide, and the balsa wood would go away, and I wouldn't have a good clean edge. So I'm going to just get this angle started. I could use my spoke shave or my plane. I'm a spoke shave guy. Anybody ever use one of these things? Man, these things are awesome. I've had that one since about 1972. Okay, so your inclination is going to be to take this and glue it like this. Don't. If you do that, what's going to happen is there's going to be a gap in here like this. And when you have that gap and you go to cut the radius, then there won't be any material there and you'll have big uglies. So here's what I intended, is that you line up the corner of this sheet like this. Hope you can see it. Like this. Right here. You could probably do something like get yourself a 20 or 30 second shim and glue in there, but what I'm going to do is I'm just going to get it lined up just like this, a little bit proud on the front. I'm going to hold it like this. I'm going to go with this super glue, just like that. It's glued, and I'm going to glue it from the inside. That. I think I got it low enough. If I didn't, we'll just cut a little bit more off when we surface this off. Repeat that feed over here. Like that. Catch a little bit on the back here like this, and that's good. Now what I'm going to do, I'm going to make that flat just like that. Reason being is these are going to be your guide to the shape. Like this, see? We're going to put another piece on top of here just like this. I'm going to go like this. Oh, I hate that noise. Close enough for now. You get the idea. That gets cut. How are we doing? Pretty good. I gotta hurry because Mama wants me to come in. That's why she came out here. I want to get through that laser Choco because that's going to come out whenever I sand this into a nice round block. I know it's bad form looking at my monitor, but I'm just making sure that I got these views where you can see them. I don't know if this point of view method is good or what. But done right, should be able to see what I'm doing and how I'm doing it. Suffer this for just another few cycles. All the laser Choco is gone. A little bit right there, who cares? Now I'm going to face the front off. Okay, this piece is going to go on like this, and then we're going to pull this in to make it line up like this. This piece is going to go in front. So I need to bevel one of these pieces. I'm going to bevel this one. Here's how I'm going to do it. I'm going to put it on this just like this, and I'm going to line it up with the edge of my bench, and that's going to make the angle here, and then I'm going to use my sanding block like this. And that's going to make a perfect fitting joint. See that? Look at that. Ah, perfect. Oh God, I'm good. not quite square. I'm gonna fix that. Now square. Okay. One thing that's a benefit of having a big tummy, you got some good work support. Okay. I try to glue from inside as much as I can, because man, this, you know, super glue, this thin super glue really gets a lot of penetration. You know, this is really just kind of a cowling, so you know, it doesn't really matter that much. Yeah, it's not quite flush. I didn't push this top piece out far enough, so we're just gonna have to take a little bit off of that front former. Some bits underneath here. Oh no, there's blue splashes all over. Clean. Line goes outside. Feet on the bottom, just like that. Hold it in place. Super glue. Yeah, I'm gonna hit it along here. Now I'm going to pull these in just like that. Yeah, mamas want me to come in. See, told ya. So, I'm gonna have to go. And we've gotten pretty much where we need to get, because you can see where this goes from here. The next step is to round our cheek cowl, and in our cheek cowl these two formers interlock like this right here, and it forms this piece like this. And you can see inside right here where the wire channel is, and here's the former of the cowl. And so we're gonna cut that former after we finish shaping this. We're gonna wait till afterwards because right now it's good and stiff. This baffle's gonna go in here, and it's probably just a little bit big, but this baffle's gonna go in here about right here. Maybe tilt it a little bit so that it looks more better, more intentional or something. I don't know. But you got to stop that air from blowing out the back. We don't want it to just come in and then go straight out the back. We want that air to go in, go around our battery and our speed controller. They need the air, and they won't get it if we don't do this. And this baffle is not critical. The only thing that I would say about this particular baffle right here is that it shouldn't be real close to this former. It should be, you know, an inch or two back from that former right here, so that the air can come in and go like this. In essence, we've got this air coming in and it's turning. If we get it too close, it's not going to make a nice turn. So here it is. We can shape this up a little bit. I've got some really nice planes. It's really expensive, nice planes. And I made guitars for a bunch of years, and the spoke shave right here has always been my favorite tool for that kind of job. This right here, cutting these long brown pieces, brown sections like this, is what spoke shaves originally were made for. You know, they used them for forming bows. Bows, like bows and arrow bows. I think you got it from here. And Mama's calling. Mama's calling, and oh, look, that glue, that's a problem. That glue, it's a problem. We know how to fix that. Man, my fuel tank leaked and that front of my plane just came all apart. Yeah. Okay. I gotta go in. You know, I'd like to stay out here and play, but Mama says I gotta go in. So I'm gonna say a day. Thank you for watching. These will be up on our website probably, I don't know, sometime towards the end of the week. They're going to be about $24, $25 thereabouts. $8 shipping. So we'll figure the shipping part out as part of that. So it probably ought to be like about $26, $28 shipping and all included. I know it's a little expensive, but we're going to include the battery and everything that's necessary to make them go. I spent a whole lot of hours developing this, and so I think the project is worth it, and the integration is fairly good. I don't know. Maybe it's not, and you guys won't buy them. That's okay, because I got me some really cool things here. And maybe they'll be a hit and you guys will buy them all up, and that would be even cooler. So I'll see you again. Have an awesome day. Bye.